Hello, welcome to lesson 3B-2, graphing quadratic equations in vertex form. So our learning target is going to be that I can graph a quadratic equation from vertex form. Yesterday we looked at graphing from standard form. Today we're going to graph from vertex form. And that's going to lead into our first vocabulary word. So go ahead and turn to your glossary and make sure that you have this added into your notes. The vertex form of a quadratic function, the definition we're going to use is a formula for a quadratic equation of the form f of x is equal to a times the quantity x minus h squared plus k, where a is a non-zero constant and the vertex of the graph is going to be the point hk. So moving into our notes, our vertex form, as we just discussed in the definition, is y equals a times the quantity x minus h squared plus k. And our vertex is going to be found using those h and k values. Our h value right here. Sorry, as the computer's frozen a little bit here. The h value here and the k value here. We're going to pull those out together to give us the coordinates for the ordered pair for the vertex right here. H is going to be our x coordinate and k is going to be our y coordinate. So we want to start by putting the vertex in the center of our table. And sorry, my computer's being a little bit laggy today. But we're going to start by putting the vertex, h of k, in the center of our table. Then we want to, just like we did in standard form, construct a table of values for x and y. Remember, we need a total of at least 5 points. Then we're going to plot the points and connect them with a U-shaped curve and arrows. So let's go ahead and jump into an example. Hopefully our computer is going to keep up with us a little bit better here. So in this equation, we're given y equals 2 times the quantity x minus 1 squared plus 3. So I need to find my h and my k. So my h is going to be found inside the parentheses here. Now if we flip back real quick, notice in our original equation, or our vertex form, that it is minus h. So even though there's a negative sign there, that's part of our normal vertex form. So we are still going to just use the 1 for the h. And for the k, we're going to use 3. So I know that my vertex is going to be 1, 3. And I'm going to put that in the center of my table. And now I need some other values around that. So I'll just keep going up on the scale, 2 and 3. And then I'll go down to 0 and -1, and I would plug these values in. So let's go ahead and start working our way up, plugging in the 0. So I would have y equals 2 times 0 minus 1 squared plus 3. Y is going to equal 2 times -1 squared plus 3. -1 squared is going to be a positive 1. Anything squared is always going to be positive. Plus 3, and we're going to get y equals 5 here. Now remember, we can reflect this over our vertex, so that is also going to be a 5. Alright, now we can plug in the -1. We would have y equals 2 times a -1 minus 1 squared plus 3. So we're going to do y equals 2 times a -2 squared plus 3, which is going to give us y equals 2 times 4 plus 3. So that's going to give us y equals 11. So I'm going to put in 11 here. Now this will also reflect across here. So I'm going to graph my points. I have the point 1, 3. I have the point 2, 5. I have the point 3, 11, which is going to go off the graph, but I can make a pretty good guess that it's going to be right about there. I have the point 0, 5, and -1, 11. So now I'm going to connect this just like we played connect the dots in the last lesson. And I have my quadratic graph. Now I want to still answer my questions. For my extrema, and I will connect this a little bit smoother down here. Remember, our extrema are going to be at the vertex for quadratics. In this case, we have a minimum, because that's a low point, at 1, 3. AOS is another way to abbreviate the axis of symmetry. So what we're looking for is that line that is going down the middle here that we are folding this parabola over, or this quadratic expression over. So that is going to be the line that goes through our vertex that is a vertical line, and that is going to be x equals 1. Right here is where it went through. Our x value was 1 the whole way through. Now on our zeros this time, zeros, remember, when it crosses the x-axis. We don't ever cross the x-axis this time, so we are going to say that there are none. Our y-intercept, remember, is where x equals 0, so that's going to be the ordered pair 0, 5. We also could have gotten that from our graph where it crossed right here. Now our domain, our x values are going to go out either way in either direction, so we're going to say that the domain is all real numbers. Now our range, we have a lowest point at 3, and then all our y values are going to be above that. So we're going to say our range is greater than or equal to 3. You might also write that as 3 is less than or equal to y, which is less than or equal to infinity. Either one of those two ways work. So we aren't terribly different from our standard form. One good feature of the vertex form is that it does give us the vertex right away that we can use to go ahead and plot that first center point that we use as kind of our anchor point. Let's go ahead and take a look at one more example. So in this one, I am given y equals negative x plus 2 squared plus 4. Now remember that our vertex form was y equals a times x minus h squared plus 4. So remember that in the formula it's a minus. Now since I don't have a minus in this problem, I have to infer that that 2 was a negative 2 before it was affected by that minus sign. Because remember, a minus and a minus give us a positive. So when I pull out my h and my k this time, I'm going to have to make my h be a negative 2, and my y is going to be a positive 4. So that's going to give us our vertex. So I will put that point in the center here, and then I will go up the other way, and I will go down. Alright, I am going to plug in my points. So let's go ahead and start by plugging in negative 1. We have y equals a negative 1 plus 2 squared plus 4. Y is going to give me a negative 1 plus 2 is 1 squared plus 4. So y is going to equal a negative 1 plus 4, which is going to give me 3. If I reflect over that vertex, that line of symmetry, I'm going to get a 3 there as well. And now if I plug in my 0, I'm going to get y equals negative 0 plus 2 squared plus 4. So I'm going to get y is equal to a negative parentheses 2 squared plus 4. So I'm going to get y is equal to a negative 2 squared is 4 plus 4. So I'm going to get y is equal to 0. So I'm going to get the point 0, 0. I reflect that, it's going to be a 0 here. So let's go ahead and plot these points. I'm going to have a negative 4, 0. I'm going to have a negative 3, positive 3. I'm going to have a negative 2, positive 4, a negative 1, positive 3, and a 0, 0. So I'm going to connect these dots, make my U shape, make sure I put those arrows at the end to show it goes on forever. Alright, so my extrema this time, I'm going to have a maximum, and that maximum is going to be right here, and it's going to be a max at negative 2, 4. My axis of symmetry is going to be my line that goes straight up and down here, the vertical line. That's going to be x equals negative 2. Notice this matches my x coordinate from the vertex. This time I am going to have zeros. They are where it crosses the x-axis here and here. And we had these on our charts as well. We had zeros at x equals -4 and at x equals 0. We got those from these values here, or from these points on the graph here. Our y-intercept also is going to be 0, 0. We can get that from the table over here or where it crosses the y-axis. Our domain, like most quadratics, are going to give us all real numbers because it's going to go forever left and forever right. And our range this time is going to have to be less than our maximum. Our highest point is 4. So we would have y has to be less than or equal to 4. You could also write that as negative infinity is less than y, which is less than or equal to 4, whichever way you prefer to write it. Alright, there is no application for 3B-2. Make sure that you complete your practice and get a good understanding of what's going on. Ask for help if you need it, and then prepare yourself for the mastery check. Alright, good luck. See you in the next lesson.